Hey guys, Ben with BigStuff here. Welcome to another Gen 4 ECU technical support video. So in today's video, we're going to be going over the integrated Transbrake bump control feature on the Gen 4 ECU itself. So back in the old days, the Gen 3 ECU did not have the ability to bump in using any type of PWM output. I was one of those guys that had to have an external controller, and in order to use my Gen 3 on my turbo application, I'd have to bump in separately using a separate controller, right? Separate controllers for a bunch of stuff. So the great thing about the Gen 4 is that there's basically no need for separate controllers anymore at all. Everything is integrated in the box as much as possible, except for some ancillary items such as an EGT module, injector drivers for big injectors, that kind of stuff. So today we're going to be talking about the integrated trans bump control. And why you need a Transbrake bump control typically is because you have a turbocharge application. You got to get on the torque converter. You've got to start making that boost. Then when you actually start making target boost, you then want to creep in. So it's very simple to wire up. It's very simple to configure in the software. And we're going to be going over both of those today. So the first thing is all this documentation or any type of technical support documentation is found on our website at BigStuffTPM.com. It's under the Gen 4 technical support section, and there you'll find all sorts of wiring diagrams, instruction manuals. You'll have these different specific cut sheets, just like this one here for the bump control, and we're going to talk about how this works. So the first thing is, let's talk about how this actually wires into your Transbrake circuit itself, okay? So the first thing here is we're going to have a Transbrake button positive wire, okay? You're going to see here that on this solid state relay, which we saw on our website, you're going to see here that it's going to be going to terminal number 2. So your 12-volt signal from your Transbrake button is going to come into terminal number 2. From there, it's going to go out from terminal 1 to your Transbrake solenoid, and your solenoid is going to be grounded, okay? This is very important that you get these wires correctly on these solid state relays. They are directional, so it's very important that you do land the wires appropriately on these solid state relays. You're going to see here that on terminal input number 4, that is going to be grounded as well. And then number 3 is going to be coming from the ECU. That is the PWM 05 output, which is on header 2 pin Nancy 3. Now that is a 12-volt DC signal. We are not pulsing a ground. We are pulsing a 12-volt signal out to this terminal, which will then ultimately pulse its solid-state relay, okay? So if you read the documentation here, it's going to go over all the specific notes pertaining to how this setup works. And the sequence of operation here is really important, which you need to understand, okay? So when the ignition is turned on to the ECU, the PWM output down here on terminal number 3, this is energized at all times, okay? So this solid state relay is always on. And the reason being is because we want you to be able to pass your Transbrake signal through the solid state relay at all times. If you want to test your Transbrake button to make sure you hear your Transbrake solenoid clicking, if you need to back up when the car is actually running, this is always on, okay? This passes your 12 volt through. If for some reason you turn on the ignition, you do not have 12 volts going to your Transbrake solenoid, you have to verify your wiring. You have to verify that pin number 3 here has a solid 12 volts to activate the solid state relay at all times so we can pass this signal through, okay? So it's very simple on how the bump feature is actually engaged, okay? When the 3-step input is triggered on the ECU, the 3-step input basically is our clutch input slash Transbrake signal, okay? That needs to be a clean 12 volts, which means we do not recommend sharing that with the actual Transbrake signal itself. That should be a clean 12 volts, meaning some sort of control relay or something else besides the actual 12 volt DC output going down your Transbrake. The reason being is because when that button is released, there can be some flyback voltage from the Transbrake solenoid. It's not good to hit that with the ECU. You can put a diode on there if you want. I typically just recommend putting another control relay off to the side, which is energized and Transbrake is pressed, and that way it just passes a clean 12 volts to the ECU. It has nothing to do with the Transbrake itself. It will work fine. It's been done forever. That's the best way that I have found to do it. Okay, so the ECU will start pulsing this solid state relay when the 3-step is triggered and the engine RPM is over 500 RPM. So whenever those two criteria are met, you will actually see this solenoid start pulsing. The duty cycle will start pulsing based on how it's programmed, which we'll go over in a little bit. okay? So when the solenoid starts pulsing, it doesn't matter whether you are in park, whether you are in neutral, whether you are in first, you can start pulsing this at any time, okay? Now, the bump input is what will actually start that process, okay? So your three-step needs to be true, which is your transbrake signal. You got to be over 500 RPM, and then your bump input has to be triggered. Now up here, you'll see in the middle, it says header 2, Y2 is the bump input to the ECU. That was our original analog trigger wire. It's a solid yellow wire. On the Gen 3 days, that's actually what started the data log or triggered the data log as far as saying, hey, get ready, we're going to do a log now. That has now become the bump input to the ECU for the Gen 4. That's a 12-volt signal, okay? So you want to make sure that when you turn on the ignition, there's always going to be a solid 12 volts applied to that input as well through another bump button, so that way you always have the ability to pulse this solid state relay. Also, it's a good idea because this header to Y2 button is what we use to update the firmware in the box. So it makes it really simple when it comes time to update the firmware, because you put the firmware on the SD card and then you hold down the bump button and boom, turn on the ignition, and now your ECU is going to start updating. It's very simple by simply just pressing that button. It starts the whole update process, okay? So that's the wiring for the solid state relay. So the biggest thing to remember here is that this relay is always on because we want to always be able to pass whenever the transbrake button is pressed, this signal going to your transbrake solenoid, okay? So how do we make adjustments to it in the software? Well, the first thing here is you'll see in the documentation, the base settings in the software should be 25 Hertz, which is your frequency, and about 20% duty cycle, okay? It's located in the generic menu under the PWMX parameters, which we're going to go look at, okay? The other thing to read up here is that if the bump is found to be too harsh while being pressed, reduce the duty cycle output 1 to 2% at a time to dial in the bump output. If the bump is not found to be aggressive enough, add 1 to 2% to the duty cycle until the car will move at a smooth pace. We typically don't recommend changing the hertz to 25 hertz unless you know exactly what your solenoid is rated for. If you just simply leave it at that hertz and adjust the duty cycle up or down, you should be able to find a very nice sweet spot. We're going to put some videos here of other cars that we work with, and you'll see how nice and smooth they do bump in, but it's never perfect. You can always dial in a little bit better. So this document spells out really good how the bump feature works. You can get these solid state relays from our website. Just search solid state relay, it'll come right up. So now let's look at the software and see how to configure it. So if I look here at my software, this is the log, okay, that actually is going over how the bump feature works, okay? So what we want to do here is we want to go into the custom section here. Now this is the new software. This is our new user interface software that we're coming out with that is currently in beta. But you can see here that this is just simply a tree menu now versus the big menu buttons that we've had for a very long time. So you will have a custom section. You're going to go in your custom section and you're going to click on the PWMX parameters. And you're going to see over here that you now have, or there is a PWM05 Transbrake bump control parameter. Now, depending on what version of firmware you have, it may not say trans bump, it may not say trans bump control parameter, it may just say PWM05, but this is the section of where you're going to want to get to it, okay? In newer firmwares, we have converted that output to be a generic pulse with output, because in older firmwares, it was simply reserved for the Transbrake and that's it. So we've now made it available for the end user to create that output doing whatever he wants. But in this case, we're going to use it for the Transbrake bump control, okay? So right here is 25 hertz. We just recommend leaving that alone. Here's your duty cycle. Right here, it's set to 21.5%. Again, 20% is where we recommend to start off with and then go up or down based on what you find. This time here is so that if you actually want to make it so that every time you press the button, it will go out a certain amount of time. So for example, just as a big exaggeration, if I put a ½ second there, that means that every time I press that bump, it's going to pulse 20% duty cycle at 25 hertz for a half a second. That's a very long time, okay? But you can put a minimum time in there if you'd like. It doesn't really matter. It's totally up to you. If you leave it at 0, it will only output based on when you actually press the button. That's it, okay? So simply adjust that duty cycle percentage. You should be all good to go. Now, if we go back and look at some logs here of how this works, you're going to see here that in white here is engine RPM. Okay, so engine RPM, this is a turbocharged car. We're coming up here, we're spooling up, we're trying to make the boost. Boost target is chief for the overshoot, and then we come back down. And then right here, you're going to see these spikes, okay? These spikes are the bump output being pressed, okay? So the bump output is pressed. This is the internal G meter, okay? Obviously, the car was sitting still. The internal G meter now, you see, goes up because the car just went forward, comes back down because the car stopped. The bump button was then pressed again right here, okay? G meter went up, G meter came back down. This is the car actually settling out a little bit. That's how sensitive our G meter is. You can see here the car was moving just a little bit back and forth, but not, you can't see with the eye, but the data logger gets it, okay? And one thing you can do here is that you can look at the duty cycle percentage of the output itself here, okay? So if I go and I grab my PWM Transbrake bump duty cycle right here, and I bring this back down, okay, you will see here that when I go active, 21.5% in this case is what the duty cycle went to. And again, we press the bump button, boom, goes to 21.5%, and then it stops, okay? So again, Transbrake input has to be true, over 500 RPM on the engine, and then we'll start pulsing that output. That's how it works. You can also go into the test modes, okay? If I go to system, again, you'll have this system menu in older sections. If you have a newer firmware, you can go in your test modes, and then down below, you'll see here that PWM05 is listed. So you can test that output if you'd like, once it's all wired up to make sure your solid state relay and everything is all working correctly. You would enable test modes, you'd press this PWM05 button, and then it'll start pulsing at your frequency and at your duty cycle. You may have to increase the duty cycle though, because 20% is actually not that much. You may have to go to 50 or even 75% during this test mode only, so you can actually hear the solenoid clicking down below if it is a spring return type solenoid. You got to remember, some solenoids actually are fluid based, so it's going to close, but it's not actually going to open because there's no fluid pressure. So if you have a spring-based Transbrake solenoid, you will actually hear that sucker clicking away with a much higher duty cycle. But then go back to your 20%. Actually, it wouldn't even matter because we're in test mode. So you could just leave this at whatever percentage you wanted to in your test modes, because it's only, and for real, is it going to run off of how you actually have it programmed in this PWMX parameters. This is actually what it's going to run at. The test mode is just simply for testing that output itself. Okay, so if we go back to our log here, you'll see here that the user pressed the Transbrake. The Transbrake, I'm sorry, was already on. That's our 3-step here, but the DAE input, that's the bump button. So it goes true, and then right there you'll see here we got the duty cycle, and then right there, there's G meter and the car's moving, okay? We can look at another one here. This is a different car. You can see here that the bump input is pressed multiple times. Right here, probably pressed multiple times because it was enough to get the car actually moving, depending on how much fluid pressure was actually in the torque converter. A lot of these guys are dumping fluid in the torque converter to get them up. A lot of times, I mean, that actually be enough fluid pressure in the converters, you got to keep pressing the button a number of times. Now you can also see here that this button was actually being pressed longer and longer and longer as the user pressed it. So you can see here that it was a pretty short amount of time. G meter's moving the car. Again, little longer, little longer, little longer, and then longest right here, okay? And the whole time, again, you can see the G meter going up and down with the car rocking around. And you can see as the car, after the G meter's pressed, it's still got a little bit of movement here. And you can see where the car finally settles out, and then away the car launches and goes, okay? We can look at one more here. Come over here to this one, and you can see here that in this case, it's very short applications will get this car moving and get it in. You can see here there's not that much time as far as the bump being pressed and this car is moving, okay? Now, what I want to show you here too is this G meter is different on this car. So instead of the acceleration underscore X axis, we're going to want to pick a different axis. And that's because of the way the ECU is mounted in the car, okay? So if I come over here to my Excel Y, aha, there it is. So in this car, Excel Y axis is the G meter. So I'll turn the Excel X back off. And now you'll see here that there's your G meter. There's the car rocking and rolling. So again, this way this car works in its Transbrake solenoid, and how it works is it doesn't need very much time at all in order to get the car moving. So you can see here the Transbrake button is always on, the bump button is pressed, and boom, the car is moving. There's your G meter rocking back and forth. There's the car settling out, and then it stops. So again, check out the videos on this video of the cars, for example, that we have our Transbrake bump feature on. It's very simple. If you just follow our documentation, use our solid state relay. You can use other solid state relays if you'd like. We obviously just recommend ours because this one always works. There's never an issue with it. Also, one thing to note here, some Transbrake solenoids actually have a ground signal that you need to run through it for control. Internally inside the case, they may be providing 12 volts to the actual Transbrake solenoid wire itself. So just pay attention to this note here, okay? If you want to provide a ground signal through the solid state relay to your Transbrake solenoid, the ground wire is landed on terminal 1, and the Transbrake solenoid terminal is wired on terminal 2, okay? Again, with the direction, that's how you want to make sure that the ground signal is passed accordingly, okay? So again, if you follow our instructions here, everything should work out great. You can see here that the data shows that the car's rocking just perfectly fine. The goal is to get the car to creep in as best as possible. You just got to make sure that depending on the actual fluid temperature and transmission, if it's really hot, sometimes these settings may be a little bit different than if the fluid's really cold and really thick. You're going to have to play with it a little bit, okay? You're going to have to find that happy medium, because in the first part of the day when the fluid is cold, it's a little thicker. It may take a little less duty cycle than when you're starting to go rounds at night on your hot lap in the car and the fluid's very hot. And then you may need some more duty cycle to actually get it to go. It's just going to take some time. You'll have to learn the combination to see what it likes. But again, this works very well. If you have any questions, please reach out to us at support@bigstufftpm.com. Please check out our website, bigstufftpm.com, for much more information about the system. Please be sure to check out our socials on Facebook and Instagram. And thank you for checking out this video.